Hello everyone. In this video, I'm going to talk about the Solidity programming language which we'll be using to write smart contracts on the Ethereum blockchain. Before starting, I would like to quickly introduce myself. I'm Amrisha Kakuti and I'm working as a software engineer at Kipro Solutions Private Limited. Kipro is a leading provider in Datalake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are: what's a contract, structure of a contract, state variables, structure, modifiers, events, enumeration, and finally functions. So let us start with what is a contract. So a smart contract is a custom logic and code deployed and executed within an Ethereum virtual machine. These smart contracts are digital and coded rules for transactions to take place between accounts. They help in transferring digital assets between accounts. They can store data, which can be used to record information, facts, balances, etc. Smart contracts are similar to object-oriented classes. They can call another smart contract just like object-oriented programming languages. Smart contracts can be thought of as small programs consisting of functions. Next, let us talk about structure of a contract. A contract consists of the following constructs. The first is state variables, structure definition, modifier definition, event declaration, enumeration definition, and finally function definition. Now let us see each of these constructs in detail. Let us start with state variable. So variables refer to storage locations where values can be stored. State variables are one of the most important aspects of the Solidity programming language. These state variables are permanently stored in the ledger by the miners. Variables declared in the contract that are not within any function are called state variables. They store current values of the contract. Now let us see how do we declare state variables on the Remix IDE. Okay, so I'll create a new contract here by the name intro. Okay. So here you can see the contract by the name intro got created. So I'll write the first line of the code, that is pragma, as discussed on my previous video, right? So how do we write that? Pragma solidity, and we give the version number 0.5.0. Okay. Next, I'll write the contract definition. So it's written as contract, that is the keyword contract, followed by the contract name. So I'll just give intro. Okay. And within this curly braces, we'll have all the constructs that I mentioned here. So let us start with how do we declare state variables. Okay. So I'll just write here state variables. Okay. Yeah. Okay. So I'll declare a state variable of the type integer, and I'll declare a state variable of type address. So these are the two state variables that I have declared. So I have declared these two state variables because I'll be using them in this contract. Okay. So this is how we declare state variables. And you can also declare state variables of type string, for example. Although since I'll not be using the state variable, I'll just comment it. Okay. So this is how we write the state variable of type string. This is how we declare state variables. Next, let us see some qualifiers that are associated with state variables. So the first one is internal. So this is a default qualifier if nothing is specified. So if the qualifier for a particular variable is given as internal, it means that this variable can only be used within the current contract functions and any contract that inherits from them. The variables with the internal qualifier cannot be used from outside for modification, but they can be viewed. So this is how we declare a state variable with the internal qualifier. So let me go back to the Remix IDE. So in order to understand the qualifiers, let me write down two functions. So one get the function and a setter function. So I'll write the function get function. Sorry. So I'll explain to you how do we write functions, but just for the time being, I'm writing it. So I'll write function get var, okay, and I'll set the visibility as public so that it can be accessed from outside. And since it is a getter function, so no modification needs to be done on the blockchain, so we'll give the qualifier as view. We'll again come across this view in this video itself, but in the later section, and it will be returning an integer. Okay, so within the curly braces we'll just return the value of a. Okay, and we'll write another setter function. So function, so I'll just write increment a. So increment where, so this is a setter function, and I'll give the visibility as public, and this I'll just put a++, which will simply increment the value of a. Okay, so before moving any further, let me deploy this contract, or let me compile this contract. So I have put here as auto compile. So for example, this wasn't checked. Okay, so if I check on this auto compile, this means that while I'm writing the code, the program is getting compiled. Okay, and if I uncheck on this, and for example, let it be checked, and if I, while I'm writing, you can see, sorry, while I'm writing a++, since I have not given the semicolon, it's giving me error. But if I uncheck this auto compile, and while I'm writing this, okay, a++, it's not giving me error, but when I compile it, it is giving me error. So it's better I put that auto compile checked. Okay, so again we'll have to compile it. Now it's fine. Okay, so I'm just checking the auto compile. Now in order to run this contract, we'll go to the run tab. So here we'll be using the JavaScript VM, which is a in-memory Ethereum blockchain, but a very simpler version of the Ethereum blockchain, and is basically used for testing. And we don't have to, so that we don't have to deploy our contract on the main Ethereum network. So we'll be provided with a few accounts with 100 fake ethers in each of the account. So this gas limit, so this is the maximum gas that can be used for a transaction to happen. So this gas, you can take it to be the transaction fee. So how do we deploy this contract? So we click on this deploy button here. So here you can see in the deployed contract, see once again, so you can get the get variable is 0. It is 0, it's giving 0 because the default value of integer type is 0. Okay, now if I increment, so I have clicked on this increment var twice. Now if I click on this get var, you'll see I'm getting 2. Now, okay, so if I'm not specifying anything, it means that the qualifier is internal. So this is how the internal qualifier looks like. Next, let us see private. So it is similar to the internal, only with additional constraints. The variables with a private qualifier can only be used in the contracts where they are declared. These cannot be used by the contracts that inherits them. So we'll talk more about this private qualifier in the section where we'll be talking about inheritance. And this is basically how we declare a state variable with a private qualifier. Next is public. So if a state variable is declared with a public qualifier, it makes them directly accessible. So let me go back to the Remix browser. So int a, so instead of just int a, I'll give the visibility as public. Okay. Now if you get, okay, I'll just cross it just to make some space. And if I deploy this contract again, here you can see I can directly access the variable here, right? And the default value is given as 0. So we can give a value to the variable right here itself. For example, I'm giving it as 4. Okay, so I'll just cross it again and I'll redeploy it once more. Okay, so you can see A. If I click on A, it's giving me 4. I'll increment. I clicked on it twice and get variable. Just give me a second. Yeah, it's giving it 6. So this is how the public qualifier works. The next one is constant. So if a state variable is declared with a constant qualifier, it makes them immutable. Hence the value must be assigned to a variable at the time of declaration only. The compiler will replace all the references of this variable in the code with the assigned value. So for example, if I write this visibility as constant, here this one, incrementing or modifying the value of A is giving me error. So you cannot modify the variable with the constant qualifier. So I'll keep it as public. Okay. So this is all about the state variables. Next, let us see structure. So structure or structs help implementing custom user-defined data types. Structure is a composite data type made up of multiple variables of different data types, and it is declared using the struct keyword. You can think of structure as a contract with no code inside it. Thus, these structures consist of only variables. Structures are used to store related data. So for example, if you want to store the information of a student, such as name, age, etc., structure can be used. Now let us see, how do you write the structure declaration? Now let us write the structure definition. So I'll just write here, just after the state variables, I'll write the structure. I'll just write here, just for the sake of simplicity, definition. Okay. So how do you write the structure definition? It is written by the struct keyword followed by the identifier. So I'll just write here as my first struct. Okay. First struct, and within the braces we'll have the variables. So for example, I'll have uint. Okay, since the age cannot be negative, so I'll just put uint age and string name. So this is how we write the structure definition. And now let's see how do we create an instance of the structure. So to create an instance of the structure, I'll just write that is the structure name, that is first struct, and I'll just give student. So this is how we create an instance of the structure. Okay. So next let us see modifiers. So a modifier is always associated with a function. It refers to a construct that changes the behavior of the executing code. Thus, it has the power to change the behavior of the function associated with it. Thus, the modifier can be thought of as the function that will be executed before the target function, so as to decide whether the target function should be executed or not by checking the current state of the contract, incoming values, current values, etc. A modifier can be associated with multiple functions. This ensures cleaner, more readable, and more maintainable code without cluttering them with the validation and verification rules. It is defined using the modifier keyword followed by the modifier identifier. Any parameter it should accept followed by the code within the curly braces. And it is declared at the contract level. Now let us see how we write the modifier declaration. So in order to write the modifier declaration, so I'll just put it as modifier declaration. So in order to write the modifier declaration, we write the modifier keyword followed by the identifier or the modifier name. So I'll just write only owner. Okay. And within the curly braces, we'll have the code. So I'll just write the code as if a message dot sender equals to owner, and then execute the target function. So what I've said written is that this target function, so the function, whichever function this modifier will be associated with, will only get executed if it is called by the same address that is stored in the state variable. So now let us write this function, that is, for example, this increment var. So let us now write the modifier here. So here I'll just write only owner. So this ensures that this function will only get executed if the message.sender is equal to the owner. So for example, okay, so this is auto compiled, I have clicked on already. Now if I run it, so for example, so I'm executing this contract using the first address. Okay, so I'll just clear this part here. So I'll click on deploy, and here you can see, for example, get variable, it's giving me the initial value as 4. Increment, I have clicked twice, and just give me a second. So yes, so I click on this get var, it's giving me 5, and I click on this increment var twice, and if I click on this get var, it should be giving, yes, it's giving me 7. Now for example, initially I deployed this contract using the first address, right? Now for example, I'll not deploy, I'll just change the address to be the third address, and I'll try to increment the variable again, and when I'm trying to get the variable, return the variable, you'll see that the variable didn't get incremented. So this is the use of the modifier. Next, let us talk about events. So events are fired from contracts such that anybody interested in them can catch them and execute code in response. They are primarily used to inform the calling application about the current state of the contract with the help of the logging facility of EVM. They are used to notify applications about changes in contracts, and applications can use them to execute their dependent logic. Events are declared within the contract at the global level and invoked within its functions. So it is declared using the event keyword followed by the identifier and parameter list, and this is terminated by semicolon. The values in the parameters can be used to log information and execute conditional logic. And event information and its values are stored as part of the transaction within the blocks. Now let us see how do we write the event declaration. So we'll write the event declaration. So I'll just write it event declaration. So how do you write that? We write the event keyword followed by the event name. So I'll just give the name as changed. Okay, and I'll pass the parameter, that is address, a variable of type address. Okay, and we'll terminate with a semicolon. Okay, now let us see how do we invoke this event from within the function. So in order to do that, so you go to the function. Okay, this is the set function. Okay, yeah, yes, so we'll write the emit keyword followed by the event name, that is changed, and we'll pass it the message dot sender. So this is how we invoke this invoke the event from within the function. Now let us see what happens when we deploy. So okay, when we click on this deploy, we'll see the deployed contracts here. So for example, I'm just returning the value, incrementing once, and I'm getting it. Okay, so now come here to this console. Okay, so when you click on this, that is the first contract increment. So here you can see log has been generated. So this is what happens when we invoke an event from within the function. For example, now let us see what happened when we didn't write this invoke. So for example, I'm just commenting this part. Okay, so I'm just commenting this part. So when we deployed the contract and we did the same things like get, implemented once, get variable. Okay, so when we click on this, here you can see there is no logs. Okay, so this is basically what is done with the event. Next, let us see what is enumeration. So enumeration helps declaring custom user-defined data types. It consists of an enumeration list and predetermined set of named constants. Constant values within enum can be explicitly converted into integers, with each constant value getting an integer value, with the first one having a value of 0 and a value of each successive item is increased by 1. It is declared using the enum keyword followed by the enumeration identifier and a list of values within the curly braces. Now let us see how we write the enumeration declaration. So we'll write the enumeration declaration. So I'll just write enumeration declaration. And how do you write it? By writing the enum keyword followed by the identifier. So I'll just write gender as the identifier, and within the braces we'll have the values, that is male and female. So this is how we write the enumeration declaration. Next, let us talk about functions. So a transaction is created when a function in a contract is called or invoked. These are the mechanisms to read and write values from or to seed variables. They are a unit of code that can be executed on demand by calling it. They can accept parameters, execute its logic, and optionally return values to the caller. A function is declared using the function keyword followed by the identifier. So we have seen how we declare function in the example that we have been using. Next, let us see a few qualifiers associated with function. So the first one is public. So if we declare the function as public, it makes the function directly accessible from outside and it becomes a part of the contract interface. Next is internal. So this is a default qualifier. This means the function can only be used within the current contract and any contract that inherits from it, and it is not a part of the contract interface. The third one is private. So it can be used in contracts declaring them and cannot be used in derived contracts, and it is not a part of the contract interface. The fourth one is external. So it makes the function accessible directly from externally but not internally. Becomes part of the contract interface. The next one is constant. So they do not have the ability to modify the state of blockchain. They can read the smart contracts, they can read the state variables and return back to the caller, but cannot modify any variable, invoke an event, etc. The next one is view. So these are aliases of constant function. The next one is pure. So they cannot read or write, that is, they cannot access the state variables. And the last one is payable. So the function with the payable qualifier has the ability to accept ether from the caller. Now let us have a quick recap of the topics that we have covered in this video. In the beginning, we talked about what is a smart contract. Then we saw the structure of a contract, state variables. Then we talked about a few qualifiers associated with state variables. Then we talked about the second construct, that is structure. Then we talked about modifiers. Then we talked about events. Then we talked about enumeration. Then we talked about the last construct, that is functions, and finally qualifiers associated with function. Thank you for watching this video. In the next video, that is Introduction to Solidity Part 3, the topics I'll be covering are data types in Solidity, value types, reference types, storage and memory data allocations, literals, integers, boolean, and finally the byte data type. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in our project. You may write to us at feedback@kpro.co.in. You can subscribe to our channel if you want to learn more about technologies like cloud, data science, ETL, data lake, DevOps, big data testing, cloud testing, etc. And you can also follow us on YouTube, Facebook, LinkedIn, Twitter. Thank you very much. Let's keep learning.